Section 2.7 is discussing linear inequalities and absolute value inequalities. In this particular slide, it's showing you that there are many ways that we can write the solution for an inequality that says x greater than or equal to 4. In this case, they're showing you on a number line. It's a little bit hard to see, so I'm going to emphasize this a little bit more. So there's a solid dot here and an arrow here. So this indicates that we're including the number 4 and anything to positive infinity. Just because the arrow ends at 9 doesn't mean it stops at 9. It keeps going. They just didn't show it the rest of the way. You're welcome to do it however you want to, but as long as you show an arrow, that means it's going to keep going forever. So you can choose which number you want to stop at. Another way to write this is in what they call set builder notation. So that's going to be curly brackets, and this says that for all real numbers x, such that x is greater than or equal to 4. That's the set. And then interval notation, which is the one that you'll probably use most commonly, is saying that you want that all values from 4 to infinity are solutions to the set, and that's 4 inclusive. So there's a couple ways that you can do the number line. I actually prefer that you go ahead and do your brackets just like you would for your interval notation, because that way you're not having to go back and forth between whether it's a solid dot like this or an open dot like that. I'd prefer that you go ahead and just use the bracket that you would need to use. So this would be a curved bracket, and then this would be a square bracket, changing direction depending on which way you're going. So if it was this way or this way. And then if you draw the number line like using these, then it translates pretty easily into interval notation. So that's it for that slide. This one, there's an error here that should be negative 4. This one is actually a multi-part inequality, a compound inequality, and it's saying that 3 plus x is greater than 7x minus 2, which is greater than 5x minus 10. So what you want to do with something like this, especially when it involves x's on both sides as well, is you want to go ahead and separate these out. So let's start with the first set. We write 7x minus 2, and then we'll write again using the other half of the inequality. And then we're just going to solve for both of those. So let's do a minus x here and a plus 2 here. That's going to give us 5. It's greater than 6x, or x is less than 5/6. And then this part, we're going to add 2 to both sides, subtract 5x from both sides. That's going to give us 2x is greater than negative 8, or x is greater than negative 4. Negative 4. So now you can see x greater than negative 4. So this is not inclusive. This doesn't say greater than or equal to. So we want to keep that open. As you can see, they did the open circle here. That's fine, but I definitely prefer that you just use the open bracket. So a bracket would be here. A parenthesis would be there. And then, and actually, so we've got a negative here. So we can rewrite this all in one. We can say negative 4 and make sure that you're writing it completely backwards. So negative 4 is less than x, which is less than 5/6. So then x less than 5/6, again, you can use the open circle, or you can use the parentheses. So this is our solution region right here. And, oh, and I forgot, sorry, for interval notation, you're going to say open parenthesis, negative 4 to 5/6, and another parenthesis. Remember, if this were inclusive, then it would be negative 4 to 5/6. So if you're including the number, be sure to use the square bracket. And if you're not including that number, use the parentheses. All right, this one is a word problem that's saying that we want the distance from a number and 5 to be 4. So we want the absolute value of x minus 5 to be less than or equal to 4. So in this case, they've put it on a number line like this. So if we go 4 out from here, that's going to be 9. And if we go 4 out from here, that's going to be 1. And then let's go ahead and do this mathematically and algebraically just so you can see that. So once we take out the absolute value signs, that's what these are, you don't know if this whole thing is positive or negative. So you want to go ahead and do both. So if it's positive, then we've got x minus 5 less than or equal to 4. And then if it's negative, we've got x minus 5. We want to switch signs and add the negative. You can do this either way. If it's more comfortable to you, go ahead and write it this way and keep it the same and then transfer it over. But either way, anytime you're multiplying an inequality by negative, you want to, multiplying or dividing, you want to make sure that you switch that sign. So let's go ahead and solve this. So we've got plus 5 here, plus 5 here. That's going to give us x less than or equal to 9, which is exactly what it shows here. And then if we'll switch this, we've got plus 5 here, plus 5 here. So it says x greater than or equal to 1, which is also what we have here. And it's inclusive. So if we wanted to do a number line, we could do something like that, where this is 9, this is 1, and we have our values in between here that are the solutions to that inequality. You can also write this in your notation. So we've got x less than or equal to 9 and greater than or equal to 1 and 1, 9. So you can write this any way depending on what it's asking you for. And the last one, this one is asking us for this particular equation, what values are, when do the x values result in a negative y value? So our equation says that y equals negative half, the absolute value of 4x minus 5 plus 3. And because we want to know when y is negative, then that means that we want to know when y is less than 0. So now we can go ahead and solve this. So we'll subtract 3 from both sides. Let me get rid of that. And that's going to leave us with a negative 1/2 times the absolute value of 4x minus 5 is less than negative 3. And then we'll multiply by a negative 2 here. And remember, because we're multiplying by negative 2, we need to switch the signs. So this is going to cancel. We're going to end up with the absolute value of 4x minus 5. Switch signs, and that's going to give us a positive 6. Now we can take this out of the absolute value sign, and we want to make sure that we consider the positive case or the negative case. So we've got 4x minus 5 is greater than 6, or we have 4x minus 5 is less than negative 6. Remember, if you're not quite okay making that jump, then go ahead and do the negative 4x minus 5 greater than 6 and solve that however you want to. So now we can do plus 5 here. That's going to give us 4x greater than 11, or x greater than 11 fourths. And then here we've got plus 5 plus 5. That's going to give us x less than or equal to negative 1/4. So negative 1/4 is going to be about here. And it's not inclusive, so we're going to keep that open. And then the other value, and that was less than, so we want all those. And x greater than 11 fourths, so about there. And then that's going to be all the values greater than that. So that's our solution set for this one.